Hi there, this is Tess and welcome to this video. Now, as you know, Microsoft has recently launched their new DP-500 exam, which talks about the tight integration between the Azure services and Microsoft Power BI. It's quite an extensive exam, so we've decided to create a separate course for it on Udemy, which I'll also link in the description. And this course will give you access to a lot of video content and also some practice questions, and we will end with an actual practice exam. So if you're interested, definitely check out the link below. I will also add a discount code for the viewers of this channel, but it's only valid for a couple of days, so make sure to do it on time. Now we will move ahead with a sneak peek of the course. So we will include 30 minutes of video content, and it will discuss Azure Synapse Analytics, the difference between the serverless and the dedicated SQL pool, and then also the visualization options using Spark notebooks and also the built-in visualization options. So you already have an idea of what you can expect on the course, but it's, as I said, it's quite extensive. So make sure to check out the exam outline and see whether this course is for you or not. All right. Best of luck with the course, and I hope I catch you with another video. So this was already a quick summary of this part, a very short part. Now we'll go a bit more into detail of querying data using Azure Synapse Analytics and the difference between the serverless and dedicated pool. Quite an extensive topic, so hold on. Now, a cloud data solution, before we start discussing the whole process and the difference between two services, we should discuss the cloud data solution in a common big enterprise. So in a cloud data solution, data is ingested into big data stores from a variety of sources. And once in a big data store, Hadoop, Spark, and machine learning algorithms prepare and train the data. When the data is ready for complex analysis, we store the data, maybe in a SQL data warehouse. Once the data is stored, you can run analytics at massive scale. So business analysts can make well-informed decisions based on that transformed data. So this is how the whole process works. So we start with a bunch of different data from different sources. We usually put it in a data lake or store it in a data lake. Then there is some transformation that happens from the data lake. We put it often in a data warehouse, and then the analytics person comes into play to really get insight from the data, and then also communicate those insights to the external parties. Now, the difference between a dedicated and a serverless SQL pool. So in a dedicated scenario, this you can really compare with the reserved capacity. So it's also the former SQL data warehouse that is now rebranded fully as Synapse. It allows you to run a query and ingest data from the business's data lake fast, but of course it demands an infrastructure setup. Data is stored in relational tables, and cost is managed by pausing SQL pool or scaling down the warehouse. The cost is incurred for the resources that are reserved. In a pay-as-you-go scenario, a serverless scenario, users query their data using data lake files, and they don't really require any infrastructure setup. The cost is automatically handled and invoiced on a pay-per-query basis, so data processed per query. Use cases in this case are, of course, data lakes, so big data analytics, of course, a lot of AI sentiment analysis as well. When you're analyzing Twitter data, for example, or emails, you would do so through a serverless SQL pool. And also when you're not really able to estimate those resources, you could also look to that serverless SQL. I've listed some of the Microsoft documentation here because I find it quite important. So every Azure Synapse Analytics workspace comes with a serverless SQL pool endpoint that you can use to query data in the Azure Data Lake. So serverless SQL pool is in fact a query service over the data in your data lake. So it's not really storing the data somewhere else, it's just a data lake. And then you're querying directly on that data lake through an endpoint. It enables you to access your data through the following functionalities. So a familiar T-SQL syntax to query data in a place without the need to copy or load data into a specialized store. Integrated connectivity via the T-SQL interface that offer a wide range of business intelligence and ad hoc querying tools, including the most popular drivers. I'll skip the next part, but it's of course serverless, hence there's no infrastructure to set up or clusters to maintain, as we already discussed, and there is no charge for resources reserved. You're only being charged for the data processed by queries you run, hence this model is through pay-per-use model. Going a bit further, if you need to explore data in the data lake, so the different features are again listed here. You have the basic discovery and exploration. You can also still build that relational structure and provide a relational abstraction on top of raw or disparate data without relocating and transforming data, allowing always up-to-date view of your data. So in the case that you have relational data, you can use both options. If you know how to really estimate that consumption, you would go to a dedicated SQL pool. If not, you can use the serverless SQL pool and have the data lake. And then also the data transformation. And so you can use those join statements to really build that logic in data to do those aggregations. And this already can be done in Synapse directly once you connect to that storage. Different professional roles can benefit, as we previously discussed already. So you have those different roles that really can collaborate, and this really brings everyone together, I think, and also allows professionals to learn from each other. So that's really a big advantage of having everything in one environment. An important function we will cover more in a later stage is the openrowset function. So this function allows you to access files in Azure Storage. So it starts with a select statement, and then from openrowset bulk. So this is the path to the folder, and then you also have an optional argument data source. So as listed here, it does have some pitfalls in terms of authentication if you leave it out. But definitely check out that function in detail, and here you have already an example. So you also have to specify the format, even though you already give it in the path name, but you do have to provide it. And so the format in Synapse is either Parquet, it is Delta, or it is CSV, but I think I got this in the next slide as well. Yes. So here's another example of a query that we can run on data that's located in our serverless SQL pool, and so within that data lake. The input formats are listed here as well, and also the data sources that you can connect to. And so you can connect to an Azure Data Lake Store Gen 1, Gen 2, but also an Azure Blob Storage. You can also use that. So the input formats, as I mentioned, Parquet, CSV, and Delta. Parquet is a binary file in Parquet format, which is a column-oriented data file format designed for efficient data storage and retrieval. It provides efficient data compression and encoding schemes with enhanced performance to handle complex data in bulk. So it's really for those big data requirements. You can easily query both CSV and Parquet files without knowing or specifying the schema by omitting the width. So then the column names and data types will be inferred from the file. So here on the left side you have another example of how this looks in practice. In the next slide I listed some other examples to really allow you to understand those different functions. And so you have read CSV files without specifying schema. So we are omitting the with statement. We also have the query set of Parquet files, explicitly specify the schema as well. Also important to note, if you're using a CSV format, what we see is that we use a first row argument in effect, we use first row equals 2 because of the simple fact that we start querying the data from the first row. Well, actually not the first row, because that's the header row, so the second row. So that's why the first row equals 2 is the argument there, as listed on the slide as well. And then also read all files in folder. I think this speaks for itself, but you also have some examples of a group by and then an order by with that T-SQL syntax. You can also query the data, and then maybe as a, let's say, data architect, data scientist, maybe you can then deliver that transformed data, that aggregated data, to a business analyst, and he or she can build those Power BI reports. Well, storing that data allows you to, or requires you to create a table for it, to store it, and an example of that is listed over here. You can also perform aggregations in that serverless SQL environment. You can do generic aggregations using group by roll-up, or you can do explicit aggregations using a group by and union all. So those are the distinction that we can use. There's also a more advanced option using group by with cubes, but I won't go into detail concerning that. But it is important, of course, to know how to perform these aggregations. So make sure to take a look at those queries and see whether you can find the difference in the syntax. Now, in the next few slides, we will go a bit more into detail regarding the difference between the dedicated and serverless SQL pool on a couple of elements, like displayed here, the table objects. We will also discuss language querying and then also connectors, if I'm not mistaken. I won't go over all of them. I just highlighted some which I found interesting. So let's go over those right now. In-database tables are not supported in serverless SQL pool. It can only query external tables that reference data stored in an Azure data lake storage or Dataverse. So yeah, this is of course with the whole data lake lying in the background, let's say. Query caching is not supported. Only the file statistics are cached, and also result set caching. Indexing for performance is also not supported in the SQL pool environment. And then lastly, with regards to workload management, maybe assigning certain resources to a query is also not supported in a serverless SQL pool. Well, because of the fact that this is done for you and you cannot do this manually, the serverless SQL pool automatically manages the resources. Going through the next slide. So here we have the query language. So on the left side we have a couple of statements. Some of them are supported in both cases, but you see there are some differences. Insert statement, update statements. You typically do this using Spark, and then the changes will automatically be available in the serverless pool. Merge statements, merging Parquet and CSV data, again, use Spark and it will be automatically reflected. Labels are not supported, and then for the dedicated SQL pool, you can use all operators, so all transact SQL operators, except the ones that are listed on the slide. Going through the next one. Security-wise, so what about logins? Well, server level Azure AD and SQL logins are supported in a serverless SQL pool environment. You also see for a dedicated SQL pool, only contained users are supported in databases. You can read over the other differences if this would be relevant for your role. Let's go also to the next slide. So they're the tools. So what kind of tools can we use to integrate with? Of course, we already saw the example of using the serverless SQL pool in Power BI as a data source. So you can use Power BI to create reports on serverless SQL pool. Import mode is recommended for reporting. Yeah, it's also some nuances there. For the rest, it's not much different from the dedicated SQL pool. They just have some more information there. But we can conclude that using serverless SQL pools as a data source is supported for common Microsoft tools related to data exploration, analytics, and visualization. All right. The last detailed view, we're almost through, is the data format. So you have those different data formats, delimited, CSV, Parquet, and so on. As we already saw, serverless SQL pool is somewhat limited in that extent, but you have those relatively common data format files like CSV and Delta Lake and so on. All right. Next up, best practices when it comes to serverless SQL pools in Azure Synapse Analytics. Best practices. So again, you can pause the video here and just read through them. This will also help you to understand the different functionalities of the serverless SQL pools and also a bit the pitfalls. What we want to highlight here is don't use Azure Synapse Studio to return a large amount of data. Azure Synapse Studio is a web tool that uses that HTTPS protocol to transfer data. Use Azure Data Studio or SQL Server Management Studio to read a large amount of data. So it's really to perform those relatively simple queries or to do those transformations, but don't use it to list billions of rows. This will take a long time and it will be very expensive. Large CSV and JSON files, ideally convert them to Parquet. Parquet is a columnar format as we discussed before, and because of the fact that it's compressed, its file sizes are smaller than CSV or JSON that contain the same data. Serverless SQL pool skips the columns and rows that aren't needed in a query if you're reading Parquet files. So serverless SQL pools of course need less time and fewer storage requests to read it. You can use partitioning as mentioned in the next bullet point, and then the other ones you can just read through them. With regards to CSV, so use parser version 2.0 to query CSV files. Try to keep your file size between 100 megabytes and below 10 gigabytes, and manually create statistics for CSV files, so add these additional metadata elements. And then some things on the var chart and so on. All right, let's go to the next slide. Data partitioning, we already mentioned it. So if your data is really large, it might be better for you to split the data. Often we see that the fact table is split in based on maybe the data column. In that case, we say, okay, we are partitioning it. So we are breaking up our larger table into smaller parts through which we can query the required tables, which will be relatively more faster and more easily to manage compared to the previous bigger file. Now we can do that using the file name and the file path function after we partitioned those files. And so the file name function, as you see in the example here, returns the file name that the row originates from, and then the file path function returns the full path of that file, and then you can use it to afterwards do that analysis, perform the query on that file and not on the entire data set. And so first partitioning the big file into multiple smaller files, and then having some sort of initial analysis on that smaller subset of data will allow you to run those queries a lot faster. The machine learning predict function, so that's a special function which is also covered on the exam. So this is a function where you or a data scientist builds up their model somewhere else, and then it tries to score it using Synapse. So it generates a predicted value or scores based on a stored module. So the functionality requires that the model is trained outside of Synapse, and after building the model, load it into the data warehouse and score it with the T-SQL predict syntax to get insights from the data. Input, the first input is the model itself. You have the runtime specified as well in a later stage, so the ONNX, neural something. Input 2 is the input data, and then the with class is used to specify the schema of the output returned by the predict function. Let's go to the next slide. So we've already seen how we can integrate an analytics platform into an existing IT infrastructure, so integrating that Power BI workspace into Azure Synapse Analytics. Then we've also seen how we can use version control to track changes to code, and then also how Synapse integrates with GitHub. How we can query data by using Azure Synapse Analytics, using the different tools that are available. We've also seen the predict function and so on. And now the final topic of this section is exploring data by using Azure Synapse Analytics. So we look on the one side, we will look at the Spark notebooks and write some Python code or some Scala and so on. And then we will also check out the results pane that is automatically built in and also includes that visualization and that graph functionality directly when you are querying data. All right, let's get started. So exploring data using Azure Synapse, we can do so by using Spark notebooks, or we can use the built-in functions. You have that chart option when you run that query, which we'll see later on. It basically allows you to view the output in a table format, or using the built-in visualization option, so actually viewing the data in a chart or a line graph or so on. And so both are possible. You just start a notebook and then you load your data and start to analyze it. So that's the Apache Spark notebook. Now you might be familiar with a Jupyter notebook. So what's the difference there? Well, it's built on a different engine. So Spark notebook is built on top of the Apache Spark, the top analytics engine for in-memory data processing. And Microsoft is really doing a lot to increase the features and improve the platform as a whole. And you can follow up on the changes with regards to notebook and just the overall changes of Azure Synapse in the monthly analytics blog. Now, the query and results pane in Azure Synapse. So you have that query pane that we know by now. And then you have the results messages, and then on the results you have table and chart. So chart has those built-in visualization options, and we'll also look at this a bit further into detail. So you can turn SQL queries and data frames into rich data visualizations. So the display function can be used on data frames created in PySpark, Scala, Java, and .NET. So this is some extra information, but for us it's just important to know that we can already perform some quick visualizations as maybe a data scientist directly in Synapse without using any code. Now we have the option to do those advanced coding and visualizations and really have that customization using that matplotlib and Seaborn libraries, for example, that you can import in Python. Now you also have Bokeh, Plotly discussed here, and Pandas, of course, for that data analysis is really useful when you're familiar with that and you want to reuse it in Synapse. It's already provided that you have the option to import Pandas. Now, some examples of that Python, because this also is expected from you to get kind of familiar with those ways that you can query to get those visualizations, and also see what kind of visualizations are possible, not the whole extent, but those initial basics, let's say. So this is an example of an pair plot that you can call, and then you have to provide all kinds of arguments like the figure size. And on the right we have a density plot. So we have a k-dplot function, and yeah, quite an interesting visualization, of course. But there's a ton of visualizations and functions that you can check out on the official pages of Matplotlib and Seaborn, which I'll also reference below. So that was it for this section. We've covered quite a lot. It was quite an extensive topic, but I hope that now you're a bit more familiar with the whole querying data in Azure Synapse Analytics, which is actually the biggest part of this section, but also you have an understanding on how we can visualize data using Azure Synapse, not just through the integration with Power BI, but also using the notebook capabilities and then the built-in results pane and there the chart option. So this was the end of this section on Azure Synapse Analytics. Now, further study, of course, you can do the Microsoft Learn pod. It'll already provided and have a lot of documentation, more than this is discussed here. You also have YouTube sources that you can go to in case you want to refresh or deep dive into some of the topics that we discussed. We also provide you with a quick questionnaire, so some test practice questions after every section. So this will follow after this video. So good luck with that, and I'll catch you in the next section.